So in this video, we're going to learn more about how atomic structure is related to the periodic table. There are different versions of the periodic table, which have different kinds of information. On the periodic table that we will be using for class, there's 4 pieces of important information that are included. So we're going to start looking at these pieces of information. The first one is the atomic number. The atomic number is a whole number, and each element has a little box or square on the periodic table. And I'm going to go ahead and zoom so we can see these things better. But for each element, there's a box. So within that box, the whole number that is on the top, in our case, for our periodic table, it is located on the top of the box in the top left-hand corner. That's the atomic number. So for example, for cobalt, its atomic number is 27. Now, the atomic number defines the element. Like we said in the last video, the number of protons for a given element for all the atoms of that element is the same, always. So this number, this atomic number, is equal to the number of protons in an element. So here we see for cobalt, cobalt has an atomic number of 27, which means it has 27 protons. Every atom of cobalt has 27 protons. Now, another piece of information we have on our periodic table are chemical symbols, and the elements are represented by 1 or more letters. So this makes it a lot easier to write out formulas and do different types of work in chemistry with reactions. So the first letter in a chemical symbol is always a capital letter. Some symbols only have 1 letter, and if that's the case, then that letter is a capital letter. If there's 2 letters, I think all of the elements now are 2 letters, because it used to be that there were some elements that had 3 letters. But the first letter is always capital, the other letter or letters are lowercase. So for example, if we look at cobalt, we have a capital C and a lowercase o. Interesting choice here, because sometimes people get confused with capital C lowercase o and capital C capital O. Capital C is carbon, capital O is oxygen. So if you see capital C capital O, that's 2 different elements. Here, if you have capital C lowercase o, that's 1 element. That's cobalt. So that's chemical symbols. You have the chemical name, the name of the element. So for example, you see here, atomic number, symbol, and then here's the name, cobalt. And in a previous video, we went over how to pronounce many of the names of the elements on the periodic table. Last piece of information we have on our periodic table is the mass number. So if you look here, this number that has a decimal, okay, it's not a whole number, it's a decimal number. And the reason why it's a decimal number is that it's a weighted average. We talked about isotopes in the last video. Isotopes are different versions of an element. And what's different about those different versions of the element is that they have different numbers of neutrons, and that means they have different masses. So if you take all of the different types of cobalt, for example, there may be some cobalt that has a mass of 59, and probably most of it is 59 because 58.983 is very close to 59. But then there's probably a small percentage of cobalt that's 58, because this number is between 58 and 59. So you have some cobalt 59, which means that the mass of the atom of cobalt is 59 atomic mass units. And then you have a little bit of cobalt in the universe that is 58 atomic mass units. So if you take the weighted average, you get this decimal, 58.983. And 58.983 would be the mass that you use for doing calculations with mass in chemistry, generally, unless you're working directly with isotopes. So those are the 4 pieces of information that we see on our periodic table. Now, I just want to talk about a few notes regarding the mass number. When talking about an atom, the mass number refers to the atomic mass. So you can have the atomic mass when you're talking about an atom. And again, as I was inferring or insinuating, the atomic mass has units of U, also known as atomic mass units. Now, we don't measure atoms, individual atoms in the lab. They're way too small. That's not going to be something you can do a reaction with, a measure on a digital scale or a balance. So when talking about amounts of an element that can be measured in the lab, the mass number refers to the molar mass. So this number here for cobalt, this is 58.983 atomic mass units for an atom of cobalt, and it's also 58.983 grams of cobalt for a mole. Now, when we talk about moles, what is a mole? A mole is 6.02 times 10 to the 23 atoms of an element. This number, 6.02 times 10 to the 23, a number that you should memorize, is also known as Avogadro's number in honor of the Italian scientist Amedeo Avogadro, who identified the importance of this quantity, of this number. This is a huge quantity. You actually move the decimal place 2 over, and then it'd be 21 zeros. It's so big that if you had a mole, 6.02 times 10 to the 23rd basketballs, you would be able to form a whole planet Earth out of basketballs. That's how big this number is. So instead of counting a dozen atoms, we're going to be counting a mole of atoms because these atoms are so small. Now, as I was saying before, molar masses, or referring to before, molar masses are measured in grams. That's the kind of units that you can measure in the lab using scales or balances. So this mass number, when we look at our periodic table, if it's an atom, it's the mass of an atom in atomic mass units. If it's a mole, which is what we're actually going to be able to measure in the lab, then it's in grams, because when you are working in the lab, what you're going to be measuring on your scale is in grams.